Beta didn't see that coming. Lesson 67, solving and classifying special systems of linear equation. What do you need today? Same stuff. Pencil. Notebook. Hallmark paper. This might be good today. Duct tape. Don't leave home without it. And if you get bored, a little light reading, maybe. Yeah. Okay. Systems of linear equations are those sets of equations that I put together with a bracket, if you remember that. So something like y equals 2x plus 3 and y equals 3x minus 1. And the deal there was that we can graph both of them at the same time and see where, hopefully, they crisscross. And that would be the one spot, x, y, where both those equations are true. That's kind of the goal of a system of equations, is to find that sweet spot where both equations are true. The x, y that you plug in would satisfy both equations. Now, they don't all do that. That's the problem. You can have actually 3 different possibilities for solutions to these things. The first one is what I just described. 2 lines that crisscross somewhere in the plane, and you get one solution. One XY pair answers. Okay, they have a name for this. This is called being consistent. And they have another name for that. It would be independent. That is, they're different equations, and consistent in the sense that taken together, there's one XY answer for that. You know that the slope of these, no matter what, has to be different. Cannot be the same slope. If they have the same slope, that'll be one of the other 2. They would never meet. They would never meet at one place if they have the exact same slope. So that's very important to take care of. And this chart that I'm going over right here is basically going to help you answer all the other questions. And the rest of it is just giving you some examples of each of these 3 cases. The second case here, maybe you can see it, maybe you can't. There's blue and then there's black right on top of it. That is when you've got 2 equations that maybe have a different form, but when you boil it all down to graph the thing, they are the exact same equation, or they make the exact same line. And so the number of solutions for this, infinity and beyond. There's every single place they share the exact same xy points. Okay, so the lines in some sense are identical. In fact, the line is the solution. Okay, the line is the solution. And this is called being consistent and dependent. Dependent in the sense that they are the exact same thing, and consistent in that you do get answers. Okay? You do get answers. Slope of these has to be the same. So that's one thing to look out for. If the slopes are the same, it might be case number 2. And then case number 3 is when you have parallel lines. See, parallel, no matter where exactly they cross the axis, these will never meet. They keep going the same up and over to each other forever. So solutions are, there are none. Null set. There are none. And this set is called being inconsistent. Notice also they have the same slope. So there are two conditions in which you'll have the same slope, but only one of them where you actually get solutions, and basically everything is solution. Here, nothing is a solution. So those are basically the only choices you get. Either your two lines cross, or they're parallel to each other, or they are the same. That's it. I'm going to go over to the camera. I'm going to show you some examples of systems of equations that fit these characteristics. And your homework is basically just to get the systems of equations into a place where you can compare them, and then you can graph to verify. So let's do that here. All right, watch me do my magic. Here we go. Let me give you a system of equations here, and I'll see if you can figure out what's going on with it. 2x plus 2. There's one of our lines, and then here's the other one. Y equals x plus 1. Now, they're not the same. They're written differently, but if we're going to turn that first one into just y equals mx plus b, we would divide by 2, and that one turns into y equals, well, 2x divided by 2 is x, and 2 divided by 2 is 1. And you can see here that we have a system of equations that are the same. So we got three choices. We got, are they consistent and independent, consistent and dependent, or inconsistent? Now, if they are the same, they are consistent and dependent. What kind of answers are they going to have? They're going to have an infinite number of answers. What are their graphs going to look like? I don't even need to do that, do I? No, I don't. Because I can't type that in. I can't type it in that way. I would just have two of the same color sitting on top of each other. Here, I'll do it this. Okay. X plus 1. And then pick another color. X plus 1. There you go. That's one of them. Let's try something else. And now for something completely different. Sort of. System of equations. Y equals 2x plus 2 and y equals 2x minus 2. First thing that you ought to notice, the slopes are the same. And that means there's only two possibilities that it could be. This is either case number 2 or case number 3. Okay, both of those have the same slope. What is different? The x-intercept. The x-intercept. So if we were going to graph these, we've got both of them at the same slope, 2x plus 2. That would cross here, 2x more or less like that, and 2x minus 2 crosses right here. Oh, don't you love that sound? Love that smell too. Parallel lines, parallel lines. And so this points us to case number 3. These lines are said to be inconsistent. Parallel lines will never intersect. There are no solutions. No solutions. That leaves us with the third case. That leaves us with the easiest, most obvious case. And that would be consistent and independent. So, here, give you an example. Y equals 1/2 x plus 3. And y equals 1x minus 2. Very first thing you got to notice is they have different slopes. Even if they're both positive, if they're not the same, they will crisscross at some place. It doesn't matter that their intercepts are different. And what matters here is their slopes. So let me graph these, and we'll just verify picture-wise that these two There will be one answer for them. There's our first line, 1/2 x, and here's the other one, and oh, right there at the end. Right there at the end. Let's see if 10 is the answer to that. Yep, 10 is the one that they share. 10 and 8 will be a solution to this problem. Let's see if that works here. 1/2 times 10. This side should equal 8. Half of 10 is 5. 5 plus 3 is 8. And let's try with this one. 1 times 10 minus 2 is 8. We have consistent and independent. And we have our answer, 10, 8, for this set of linear equations. The rest of everything you have to do is just looking for that. Another way they say that you can check, but only if your answers are whole numbers, is that you can make a table. That would be using the little second button and the graph button. And you're going to scroll on down until you find the pair of y answers that are the same with the same x. And 6 and 4, 6.5 and 5, 7, 7.5. There we go. They're both 8. When x is 10. So there is our answer. Now that's all for that. We'll see you soon for lesson whatever. 68? Yeah, 68.